Today we're going to cover horizontal vertical lines. We're going to cover the concept of slope, writing equations, linear equations, and then parallel and perpendicular. So let's go ahead and get started on that. First, we're going to deal with vertical and horizontal lines. Vertical lines whose equation can be in this form, where K is a number. In the case of a horizontal line, it can be like that. Now, the reason for that, this simplistic equation that you have, if you have graph paper and you have a vertical line, what you see on that vertical line is a series of y values and a series of x values. Now, in this particular case, my x value is 3. Okay? Now, if you notice, I have all of these y values. Here's y equals 1, which would generate the point 3, 1. This one is 2. I would have 3, 2. Down here, I would have -4, which would have 3, -4. So what you see with these is we have a series of points vertically aligned where the x value is always the same. And that's why we have this formation on this equation. In this case, our equation would be x equals 3. Because y, no matter what it is, the x value will always be 3. Now, in a similar manner, for horizontal lines, if I had this horizontal line, okay, in this particular case, my y value is 3. Again, I just conveniently chose 3. Okay, this of course being the origin. There. Now, with this, I've got a succession of points out here. Let's look at the value of those points. Well, here we have -1, 3. -1, 2, 3, 4. +3 for the y. This one, I have the value +2, but 3 again. Notice in all cases, the y value remains the same. It is constant. Okay, and in this case, 3. So when we deal with naming horizontal and vertical lines, we're basically saying we're locating it on the intercept of the x and the y axis, and then this number, whatever k is, tells you where that will be vertically or where it will be horizontally. We have the equation 5x equals 10. We simplify it, divide both sides by 5, and we get x equals -2. What that means is the first point we're going to have on this line is the point x is -2 and y is 0. Because out here, there is no b value shown. So we're going to graph that. And then In this case, there is no y-intercept because it is a vertical line. Now, there are lots of points on this line. Once again, like I mentioned before, although this one is the point -2, 0, because it is neither above or below, this point in turn would be -2, +2. This point would be -2, -4. And as you see with all of these points, the x value is constant on this vertical line. If you wanted to graph the points, basically what this is saying is you can let y be anything you want it to be, but x will always be 6. What about horizontal lines? Here, you tell how high or how low above the x-axis that it is, and that will be your constant. We got the point 0, 2 right there. Well, you know, we also have the points -2, 2. We have the point -2, 5. Excuse me, -5, 2. Over here, we have the point +3, 2. And in all cases, we have a constant remaining y equals 2 value. Another equation. In this case, we end up with a fractional value. Well, 7/4, 4 goes into 7 once with 3 remainder. So 7/4 is actually 1 3/4. So a -1 3/4. You don't need to go through this. You need to just simply realize that we're going to have the value y is -1 3/4. Here, 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 everywhere, just as we've described with other values. Now we're going to go into introduction to slope of a line. Slope measurement of a line through space. To measure it quantitatively, we take 2 points and we determine how much rise compared to how much run. Rise over run. Now, what are rise and what run? Well, this is vertical change. Or we could use the word delta over horizontal change. Okay, so we have our vertical change, how many feet higher it is over how many feet left or right it is, or how many feet down it is. Once again, I take that and we use slope as a ratio. You expressed as a fraction, it can be a decimal, or it very likely could be as a percentage as used in highway and railroad grades. Of course, the percentage is parts out of 100. In this particular example, the slope, the angle that this is at, is how much change in the X compared to how much change in the Y. Okay? Here we have the Durango-Silverton Railway, Durango, Colorado. This train leaves the city of Durango approximately 10 feet above the Animas River, which is down here, 400 feet down at this particular location. Now, this train couldn't just go vertically up like that. It had to have a long set of curves and flat spaces to space this out so that it can travel upwards. A train can only increase approximately 1.5%, which translates to 18 inches in 100 feet. So if I took this classroom and the next two, and I started at this point, I could only draw a line that would be 18 inches higher at the end of the third one. And that would be the slope that's acceptable. Now, what do they do if they occasionally have steep slopes? Well, they've got two choices. They can add extra locomotives. They can dump sand on the tracks. They have a provision for that. Or they can have fewer cars. By the way, that's me, hanging out there like an idiot, taking pictures. I didn't take this one, obvious. This is my home garden railroad. These are called G-scale trains. Each one of these cars is approximately 6 inches tall. If we look from here, this level to that level, it's almost 18 inches higher. Well, there's no way this locomotive, it's actually electric, could hit that sort of a grade in that short of a distance, which happens to be about 10 feet right there. So what I had to do is I had to put in this switchback, this curve, to lengthen the run compared to the rise. Okay, by lengthening the run, I decreased the steepness of the overall track. Here's my home station. This track going up here at one time was fairly steep. It was about a 2.5% grade. That was unsatisfactory. Since I was starting engines from a dead stop here at the station, often I would spin the wheels. So I went in there. That happens to be vinyl artificial wood, 3/4 of an inch thick, 1.25 inch thick. I put that in, raised the track that much, with gravel to make it look nice. And now I had a much reduced slope that I could use with my trains. Here's just another view of my layout with some of the villages and the trains. At one point, I had the track actually laying on the ground. And because of that, at some points going this way, I had a 4.7% grade. I couldn't do it. I could only go downhill this way. So I built a trestle. This is the basic framework for the trestle. That's called a ladder system. And with that, I decreased that elevation increase to 1/10 or 0.8 of 1%. Here's that same trestle that you saw a few minutes ago when I put in the extra material to make it look like a trestle. And here's a new project that I created. By the way, this piece from here to here will be raised to the level of that string. And this curve is perfectly level into that area. Now, notice the area right here for the next picture or two. The gap right there, that and this are now the same. And you can see this track is level coming out of there. Here's coming around that curve that you saw. I built the mountains and the hillsides using a 1/4-inch wire mesh and a mixture of stucco and concrete mix to make it look a little better. Let's talk about slope in engineering. Here's an old silo in a farm town. Although there's a fairly new locomotive, this building's probably more than 100 years old. The slope of the roof, as you see, it's quite steep in every area, okay? Another example of the use of slope. This is on the Kansas Turnpike between Emporia and Laredo. Why didn't they just go straight up instead of taking this long curve and around? Well, because to go straight up would have been too steep and would have gone against the guidelines that the turnpike had for steepness of track. So they increased the run to reduce the angle of the slope. Here's an extreme example of switchbacks. They've got some kind of like this in Colorado. This one doesn't happen to be Colorado. But again, to get from this point to this point, that would have been impossibly steep. So they added all this extra run distance to get you up there. And here's another example. Imagine that tractor trying to come straight up this way. It would be almost impossible and incredibly dangerous. There's just a night view of a highway, which brings us to a page in your handout packet. In this handout packet, you should have this page, and I believe it's page 7 if I recall, and it shows you the basic slope formula. Now, what this is saying is the amount of change, the difference between the y value in one point and the y value in another point, divided by the difference of the x value of one point divided by the x value of another point. These are called subscripts. They are not powers. They are just identifiers to say this is the y value that goes with point 2, and this is the y value that goes with point 1. You notice that this formula can go either direction, but if you start with y1 on the y's, then you better start with x sub 1 on the x's. Ultimately, you will get the same answer. Now, we've already talked a little bit about y equal mx plus b. Later tonight, we'll use this. It's called the point slope formula because you have a point in here, x1, y1, have a given slope. Here again is the formula for a horizontal line, the formula for a vertical line, and we'll talk a little later about perpendicular and parallel lines and lines that just intersect. Now, the slope, again defined as rise over run, okay? So we're trying to determine basically what is the ratio that defines this angle of the ladder. So we have the rise 15 over the run 5. The change in the y over the x, the rise over the run, and that simplifies to 3. Now, most of the time, we're going to use this in fractional form because we can go up 3 spaces and write 1 space in terms of determining our slope. And I'll demonstrate that more in a few minutes. That means they go up 3 feet vertically for every foot horizontal. Buildings and homes. Okay, in this case, they have a slope that simplifies, to 1/5. 8 over 20, rise over run, equals 8 over 20, which simplifies. 4 goes into both of those. So it simplifies to 2/5, or 40%. Now, again, most of the time we leave it in this form. Typical house construction in the Wichita area, they use roof pitches. It's called pitch instead of slope. Values like 4/12, a rise of 4 feet for a run of 12 feet. That's a fairly shallow pitch roof. Kind of like this drawing, very similar. Now, on the other hand, what if you've got a pitch of 6/12? That means it goes up 6 inches for every 12 inches of run. Or what if you've even got an 8/12? My house happens to be a 2-story house. On the main part of the house, I have a 6/12 pitch. That's steep enough that you're very uncomfortable while up there on the roof. Now, the backside of my garage is an 8/12 pitch. On that, when I had a new roof replaced, they had to nail down boards to keep the workers from sliding off the roof. Now, what's the value of different pitches of roof? Whether it be a shallow pitch roof, like I said, typically the 4/12, a flat pitched roof, or a 6 or an 8/12 pitch. Let's consider Florida. Florida just got hit by a hurricane recently. They had winds in excess of 100 miles an hour. What would be better? A shallow roof that the wind could glide over, or even flat, or a steep roof that the winds would hit head on? Well, in Florida, the shallow roof would be preferred. Now, what about in Kansas? Once in a while, we might get a winds in the 60 to 80, 90 mile an hour range, but those are rare. But we do get hail a lot. A hailstorm hit Wichita a few years ago with grapefruit-sized hail. In some cases, those grapefruit completely penetrated the roof of houses. In all cases, those were shallow pitched or flat pitched roofs where they broke through. A house like mine that had a steep roof, the hail just shucks off. So in our part of the country, it's to our advantage to have a steeper roof. Let me get rid of this. And let's actually learn how to use the slope formula we looked at a few minutes ago. Okay, I've got 2 points. Okay, and this is the formula. Now, why do you suppose they put this disclaimer in here? Because you can never have 0 in the denominator. At least that's what we've always told you. But there is one exception, and we'll talk about that exception in a few minutes. Okay, the rise over the run. Now, here are 2 points. They're going to work this problem in a way that I don't care for. They're going to call this point 1 and point 2. I prefer to call this one point 2 and point 1. And I'll show you why in just a moment. Okay, here we go. They are calling this 1 and point 2. So what did it do? Here they've got these. They're putting it in here. Now here's the formula. I've got to have the y value from point 2, this one, minus the y value of point 1, right here. Then I've got to have the x value of 0.2 over here minus the x value of 0.1. And you're kind of crossing over because you've got to keep the same relative position of the values of the points. Now, we'll continue, let them go ahead and finish working this. You get 3/16, which reduces to a slope of 1/2. By the way, we use the letter M to denote slope in algebra. Now, the reason that I prefer to call these the other way, if I have this one, 1, -1 as 0.2, and I have 7, 2 as 0.1 in that formula, okay, then it makes it quite easy. I take the y value of 0.2, -1, minus the y value of that over the x value minus the x value. Now, let's see what this works out to be. 1 minus 2 gives me -3. 1 minus 7 gives me -6. The negatives cancel. I get 1/2. Now, why do I prefer this? Because I simply go left, right, left, right, left, right, left, right. And you're less likely to make a mistake than if you do that. So I always suggest that you call the first of the 2 points you're going to deal with 0.2. Now, let's look at what this value gives us. That means that we've got a rise and a run of 1/2. If we go up 1, we go over 2. We go up 1, we go over 2. We go up 1, we go over 2. And that's how slope works on this. Okay? What if we've got this? Well, let's just work it this way. In this case, for my slope, I'm going to have -4 minus -1 over 3 minus -5. Okay, that divides. Got to convert those. -4 and +1 make positive or make -3. Okay. Here again, these cancel. 3 plus 5 is 8. So in this case, the slope is -3/8. Now, this -3/8 can be expressed also as +3 over -8, which is what you would have gotten if you had reversed those 2 point orders. Okay, and both of these are equal to just simply -3/8. These 3 values are all equivalent values, and it makes a difference when we're graphing. Graph paper. Okay, we know that our slope is this. Now, I'm just arbitrarily pick a point right now. This is not true to this equation. Okay, because we're not ready to do that yet, but I'm just going to pick this as a starting point. So I can either go down 1, 2, 3, and over 1, 2, 3, 4, 5, 6, 7, 8. or I can go up 3, 1, 2, 3, and negative direction 8. And you see they all go through the same line. Okay. Now we'll go ahead and let them work this. Okay, as I told you, that was the answer if you reverse the order number of what you called each point. And here is that same graph that I got. Except this one's actually, mine was at the same angle up here because I just arbitrarily picked the starting point up here rather than doing what it actually is on this problem. When we get to the point slope formula, we'll be able to figure the exact placement of that line. Okay, another point, we're going to skip over that problem and go to this one. Find the slope of the line that has these. Okay, in this case, they chose this to be 0.1, and they chose this to be 0.2. Okay. Uh-oh, we got a 0 in the denominator. Here's that one exception that I told you about. Now, if we try to, if the question is, what is the slope of that line? The answer is undefined. Okay, undefined. Now, what that means, this also happens to be a vertical line. Okay, XY axis, vertical line. Okay, what this is saying is that that line, and you won't find this worded this way in a textbook, but logically for you, is that line is infinitely steep. We can't measure it. Therefore, it's undefined slope. Now, let's consider some slopes. What if I had the slope of a line that was 1 over 1? We go up 1 over 1, up 1 over 1, up 1 over 1. And in this case, I'm letting it pass to the origin. Down 1 left, down, down left, down left. Okay, this is a slope x equals 1 over 1. What if I had a slope of x equals 3 over 1? Starting here again, I would go up 3 and over 1, up 3 and over 1, up 3 and over 1. And this one would be at a much steeper angle. What if I had a slope of x equals 10? Well, in that case, a slope, this is m equals 1, m equals that, m equals 10. This one is slope undefined. Okay, that one. Now, a slope 10, I'd have to go up 10 and over 1, up 10 more and over 1, down 10 and over 1, down 10 more and over 1. And as you see, it's still getting increasingly steeper. And then you could do 100 over 1 and 1,000 over 1. and a million over 1, and a billion over 1, and without getting silly about it, you can keep trying to get infinitely high of a slope, but you would never reach it quite. So therefore, vertical lines are undefined, unmeasurably steep slopes. So that's kind of the way you can think of it. It's undefined, unmeasurably steep slope. Okay, there's the graph of that. Now, I got careless on this. If you notice on this particular problem, notice here, negative 3x value, negative 3x value. That x value defines where the vertical line is. If this were 5 and 5, then it would be over here. Okay? So in my case over there, I ignored the negative signs up here, and I shouldn't have. Okay, back here, another set of problems. Let's look at these. Same x value. If they have the same x value, that means they're all going to be 5 spaces over. One, two, three, four, 5, and you're going to have a vertical line where everything is 5 spaces over. No matter what y is, the x is always going to be 5. So that is a vertical line. In this case, note that the y values are the same. Okay? Graph paper. Go up 2 spaces high for y and draw your line. Okay? This is a horizontal line. What is the equation of this line? The equation of this line is y equals 2. Okay? That defines this horizontal line as being too high no matter what the x value is. Now, what about the slope of this? How much does it go up and over? It doesn't. It stays at the 0 level. So m on a horizontal line is always equal to 0. Now, there's something I don't want you to do. I don't want you to ever use the phrase no slope. That doesn't mean anything. It could be confusing. Are you meaning that there is undefined slope, or do you mean it has 0 slope? So we do not use the phrase no slope. You simply say if it is a horizontal line, that the slope is equal to 0 and that it's horizontal. If it's a vertical line, you say the slope is undefined, oh, it's erased now, undefined, and that it's vertical. Okay, so that's the way you define slope for vertical and horizontal problems. Notice what kind of an answer you get on a horizontal problem. You get a 0 numerator. Okay? You had both of these the same. You're going to subtract each other 0 every time if both y values are the same, because anything minus itself equals 0. So here's the slope of a horizontal line. Parallel and perpendicular. Those are a pair of parallel lines. In this case, in order for them to be parallel, they must have identical slopes. Now, there is a way that we denote that. For parallel lines, 2 bars to denote parallel lines, M1, the slope of the first line, must equal the slope of the second line. And that's a hard and fast rule. Now, again here, they're just trying to discount it being horizontal or vertical lines. Notice on this statement, now this is for perpendicular lines. What this statement is trying to say is that compared to the slope of the first line, for the second one, you have to have the opposite sign and the reciprocal of the first one. Let me show it in this way. Okay. If I had a slope of 3/2 for my first point, for my first line. If I wanted to have a perpendicular line to that, then the slope of the second line would have to be -2/3. In other words, opposite sign, because there's a hidden positive here, and the reciprocal. And when you have that, these lines will meet at right angles, whatever their total space is. Now, vertical and horizontal lines are automatically perpendicular. Okay, here's an example. The slope of this line is -7/2. It's going downhill because of that negative sign on the slope, on the M. Okay? I taught you about y = mx plus b previously. And this M is the slope. On this one, we've changed the sign and we've gotten the reciprocal of the fraction. So these are perpendicular. This one goes up 2/7, up 2/7. This one goes down down 7/2, down 7/2. Okay, suppose the given line has a slope of -5. That's -5/1. Find the slope of a line parallel to it. Well, if it's going to be parallel, it's going to be the same. Find the slope of one perpendicular. We've got to change the sign, and we've got to take the reciprocal. In this case, slope of a line is -4/3. That means it's going downhill left to right. Find the slope of one parallel. Well, it's going to be the same. Find the slope of perpendicular. Then it would be +3/4. Now, 2 points are given. Without graphing them, tell me whether they're parallel, perpendicular, or neither. Okay? That means I calculate the slope of these 2 lines. So here's the first line. And I get a slope of 2/1. Here's the second slope. I get a slope of -1/2. Okay, I have opposite sign and I have reciprocal. So these two lines are perpendicular. Okay, we've got another two sets of points. Whoops. Okay, we would find these. Let's go ahead and do these. I'm going to call this point 2, point 1. So I'm going to go -1 m of the first line is -1 minus 6 over 4 minus -3, which equals -7 over +7 equals -1. Okay, the slope of the second line. Again, I'm going to call this point 2, and I'm going to call this point 1. So I've got 3 minus 0 over -1 minus 2 equals 3 over, in this case, -3 equals -1. So what do we know about the slopes of those two lines? They are parallel. Now, what if you had two lines and it was neither parallel or perpendicular? Then that just means that they cross in space somewhere. And we'll figure that out where a little later. Slopes can be used for predictions. Number of males 20 years or older who are full-time workers has grown since 70. Approximately 43 million then. By 2010, it grown to 69 million. Here's a graph of this. In 1970, there were 43 million. These are years in increments of 5s. This is number of workers in terms of number of millions. Okay? It tells us in 2005, right here, that there were 65.4. So we can take this value and that value, and we can find the slope of the line. And you get, in this case, whoops. There. You get an increase of 0.64 or almost an increase of up to over 3. Well, here's your graph. What if you wanted to know what about 1995, or what if you wanted to know about 2024? Well, if you continued this line, you could predict how many workers there would be in 2024 if there weren't some major event like COVID, for example. Now, school districts use this information. When do they need to build a new building if their population is growing? Well, the answer is 10 years. They need to begin 10 years before they need it. So what they're talking about, let's say if they figure out according to one of these charts that they need a new school building right here, and it would be filled. Well, that means 10 years earlier, they better start the planning. 5 years before, they start the building. And 2 years later, they can put students in it and allow growth to capacity. So that's just one simplistic example of how these kind of charts can be used. Equations of a line. We've talked about this already in class, y equal mx plus b. That's the workhorse form that makes it simple to graph. This is the y-intercept value, and this is the slope value. This is your anchor point, and here's your up and over when you get ready to graph. Here we're defining the y-intercept because 0 is always the x value on the y-axis. Now, this equation, what we need to do is convert it to slope-intercept form, y equal mx plus b. So what do? We take this 3x to the other side. Now we're going to divide both sides, every term, by 4. Well, that would simplify. So you end up with y equal negative 3/4 x plus 1. Now let's talk about this line. This line, if we get ready to graph it, first thing we know is we know that the y-intercept is the point 0, 1. And by the way, if a problem asks you to define the y-intercept to give it, you must give it in point form, not value form. Okay? So at any rate, right here is the y-intercept at the point 0, 1. Now, from that point, we in turn are going to go either down 3, right 4, or we're going to go up 3 and left 4. Okay? Because this indicates in the negative direction, in the negative direction there. And remember, this is rise over run. So from this anchor point, the y-intercept, then we can go down 1, 2, 3, and to the right, 1, 2, 3, 4 places. Okay? We could also, from here, we could have gone up 1, 2, 3, and left 1, 2, 3, 4. As you see, these create our line. Okay? So that's how easy it is to graph from the form y equals mx plus b. Okay, that's just telling you what I said already. Another one. Now let's just start graphing some that are already in this format. First, we plot the y-intercept. This is the problem that I just did on the board a moment ago. This is showing you going back and forth. I can have the negative here, or I can have the negative there, showing going upwards or downwards from my anchor point. Again, a recreation of the same graph I did a moment ago. A little pretty. Now, let's determine, let's graph perpendicular or parallel lines. What we need to do is determine if they are. Well, if two equations are in y equals x plus b form, it's real easy to determine if they're parallel or perpendicular just because of the slopes. So in this case, they have exactly the same slope So without doing any work whatsoever, you can simply say these two lines are parallel. By the way, for a little bit of silliness, did you know there are parallels in parallel? Yeah, I know, that's bad. Now, in this case, they talk about the y-intercepts. You've got a different y-intercept. In this case, 7, in this case, -1, but the slopes are the same. Okay, what about these two lines? Well, we've got to simplify them first. Okay, here's simplifying the first one. Here's simplifying the second one. Here we get a slope y = mx + b of -3/2. Here we get a slope of +2/3. If you notice, opposite signs, reciprocals. So therefore, these two lines happen to be perpendicular. Okay? Let's graph that. The first line here. My y-intercept is +1.01. From here, there's my two ways of graphing from this point. I can go down 1, 2, 3, and over 1, 2, and down 3 and over 2, or I can go up 3, 1, 2, 3, and left 2, and up 3 and left 2. And there is my first line. Okay, and it has a y-intercept of +1, 0, 1. My second line, -2, is my y-intercept, the point 0, -2. From here, I can go up 2 and over 1, 2, 3. And I can go up 2 and over 1, 2, 3. Or I can go down 2 and 1, 2, 3. And down 2 and 1, 2, 3. And here is my line. Now, if we measure these two lines, they meet at a right angle. Now, you might ask, how did I do this going down part from this m equals +2/+3? Well, you can also write this as m equals -2/-3. So if you could write this one these two ways, you can write this one these two ways for going up or down from the anchor point. And these lines are perpendicular. Here's a couple more. We've got to do a little bit of arranging. Uh-oh, what kind of a line is this one? Well, this says y is defined as 6 everywhere, so that's a horizontal line. Okay. Now, on this one, we put it in y = mx + b by taking this x on the other side, and we get a slope of -1/1. So -1/1. Equation, that's a horizontal line, so the slope is 0. Okay, in other words, 0 times x + 6. These lines, you notice on these two, they are neither parallel nor are they perpendicular. This one has a slope of 0. That one has a slope of -1. That means that those lines just intersect somewhere in space. And here's some we could try, but for right now, we're going to continue. Now, we're going on to our next step. For this, on your formula sheet, on page 7 of your handouts, you're going to need to find the one that says the point slope formula. Okay? Find the point slope formula. In this problem, we are given the slope m, and we are given a single point. Now, furthermore, anytime that a test problem starts off, find the equation of the line. If we're talking about linear equations, you're going to use ultimately this point slope formula. What is the point slope formula? Well, the point slope formula looks like this: y minus y sub 1 equals m times x minus x sub 1. This y sub 1 and x sub 1 are the respective values of that point. In this case, the slope is -3 in this particular case. Okay, so we can put this -3 into here. I'm not going to have you do it the way that they're showing in this example. What I'm going to have you do, we're going to go back up here, and I'm going to have you work this one using that formula. There is another way, but it can be confusing and error-prone. This way, very solid. So y minus, in this case, -4 equals m, -3, times x minus 1. I don't need a parentheses just for the 1. Here, I get y plus 4 equals -3x plus 1. I distributed here and I distributed there. Now I need to take this 4 over, so -4 minus 4. Y equals -3x minus 3. And that's my equation of that line. And that's the way I want you to do any problem that says find an equation of the line. Okay? Here they're formally introducing that. Now, again, this is just kind of repeating what I told you. Here's the same problem we just did. Okay, and there is our equation of the line. What if we have this one? Well, y minus y1 equals m times x minus x of 1. 1 point on the test, partial credit. Y minus -6 equals -5 times x minus -2. 2 points on a test, even if you mess up the rest of it. Y plus 6 equals -5x And don't forget, I've got to do this. So -5 times +2 is -10. Now I'm going to subtract 6 on both sides, and I get y equals -5x minus 16. And there's my equation of the line, given that point and that slope. We got something different this time. I didn't give you the slope. I did give you 2 points, but I did not give you the slope. So this becomes a two-step problem. First, you have to find the slope using the slope formula. Then you have to use the point slope formula. So here what they've done is they've used this, they put in the values of the 2 points respectively, and they got a slope of -1/1. So now we have the slope, and now we can pick either one of these 2 points with the point slope formula. Now, which one is better? The one that has the easier numbers in this problem, okay? And it just depends on the numbers of the problem. So let's put that in here. Here's the formula. Here's the substitution. We've done the distribution. Okay? So formula, substitution, distribution. Now, we got to take this 1 over to the other side. So there is our answer. So if they just give you 2 points and they tell you to find the equation of the line, then first you have to find the slope, then you have to use the point slope formula. Find the equation of the line passing through this point and parallel. Okay, we're throwing something extra in here. Find the equation of the line. That means that I'm going to need y minus y sub 1 equals m times x minus x sub 1. Somewhere in this problem, I'm going to need that. Now, it doesn't tell me the slope. It says that the line going through this point has to be parallel to this line. Now, what that's implying is this line is different than the line that goes through this point, but got to depend on this line to get the slope since they're parallel. What do we got to do on this? Well, we've got to put that in y equal mx plus b form. Take the x to the other side. Okay, isolate that y. So what is my slope in this case then? M equals -4/1. Okay. Well, that's going to be the same slope that we used with this point. So now what are we going to do? We know that the slope is -4. So we're going to take -4 and this point they give us to find the line. Here's my equation that I told you, the point slope formula. Here's the substitution. Here's that -4 that we had for a slope. Here's the y value, here's the x value. Continuing. We're going to do some simplifying here. We're going to simplify there. Now we're going to distribute. Now we're going to take 3 to the other side. So that leaves us y equals -4x plus 11. So what that means is this is the equation of a line going through this point that is parallel to that one. And we could graph those. Over here we had y equals negative 4x plus 8. Graph paper, this one, okay? We start at positive 8. We go down 4 and right 1 because we got negative 4 over 1 or 4 over negative 1. We go down 4 more and over 1 more. Here is my line. Okay? Now, for the other line, this one. For my slope, I can have negative 4 over 1, or I can have positive 4 over negative 1. This one starts at negative 11 down here. Okay? The point 0, negative 11. So, from that, I can go up 4, 1, 2, 3, 4, and left 1. 1, 2, 3, 4, and left 1. 1, 2, 3, 4, and left 1. And as you see, those two lines are parallel. And there they are a little prettier than I drew them. Here's that negative 11 intercept. Here's that positive 8 intercept. Okay, now, let's find the equation of a line. That means we're going to have to use the point slope formula that goes through the point 4, 3 and is perpendicular to some other line. So the first thing we've got to do is we've got to put this in y equal mx plus b form. Got a little bit of arithmetic there to do. And here is that equation equivalency. Okay, I'm going to write that over here just so we've got it. Y equals 82 thirds x plus 1. That means the y-intercept is the point 0, 1. So there it is. Now, based on that, the slope of this equation over here is negative 2 thirds. But the instructions find the line that's perpendicular. So if the slope M1 like so, then slope of the second line has to be positive 3 over 2. Okay. Now, here's my perpendicular slope. Now what I'm ready to do is I'm ready to take this perpendicular slope and this point and use the point slope formula to find the new line. Okay, so here's my new slope, slope of the second line, and here is my given point. Here's the formula, the substitution, the 3/2, positive 3/2, and the values 4 and 3. Now, in this case, we got that. We're going to take the 3 over to the other side. Here's the equation of my new line. This line and the other line are indeed perpendicular. Okay. Now, here's a summary for you. Standard form. I suggest you take a picture of this one. Horizontal line, we define it by what y always is. A vertical line, we define it by what it always is. Here, the slope is 0. Here, on a vertical line, the slope is undefined. And the y-intercept is whatever this is, 0. Okay, the slope-intercept form of the equation. Y equal mx plus b. Here, the slope is -2. The y-intercept is the 0.505. Okay? And this here. And then finally, the point slope formula. You take the given slope. In this case, they use this example. And then you take some point that they give you. Okay? And you put it in there. So, this is your basic formula. Anytime the problem says find the equation of a line, it will give you an answer in this format. Okay, let's do another one. Perpendicular to the x-axis. Well, what is the slope of the x-axis? Well, it's basically a horizontal line, so the answer is m equals 0, and the equation of the line is y equals 0. Okay, so that's information about the x-axis. Now it wants a slope perpendicular to this one. Well, if this is a horizontal line, then a perpendicular slope is a vertical line. Now, this point defines where it's vertical. In this case, 1, 2, 3, 4 over. Okay, so it's that vertical line. But what is the slope of a vertical line? Because vertical and horizontal lines are always perpendicular. Well, the slope of this one is undefined. But we can still come up with a line because that tells us the always x value. So the equation of this is x equals -4. Slope undefined. In this case, there is no y-intercept. In this case, the y-intercept is 0. 0, 0. And you could do this one, but it's bigger numbers. And that's the point at which we're going to stop this particular lesson. Good luck with your work in Alex and on exam number 1.